Assalamualaikum and a very good morning. Today, we are from Group F would like to present about our experiment, Polarization of Light. Without further ado, I will go straight explain about the main objective for this experiment, which are to observe the change in light intensity when passing through the polarizers and to observe the intensity of light when using optical active liquid. So, the problem statement for this experiment is that polarization can change the intensity of light, and while using optical active liquid, we also can alter the polarization of light. However, while using non-optical active liquid, we cannot alter the polarization of light. Next, moving on to the introduction. Light is electromagnetic wave, as the electric field of this wave oscillate in a perpendicular to the direction of the propagation wave. So this phenomenon of unpolarized light occurs when the direction of electric field is randomly fluctuates. There are many commons of unpolarized light such as sunlight, LED, spotlight, and incandescent bulb. So polarization is a phenomenon caused due to the wave nature of electromagnetic radiations. So in order to produce polarized light, we need a polarizer as a filter, so which allow a single wave of a polarization to pass through. There are three types of polarizations, which are linear, circular, and elliptical. So as for the linear polarized light, it limits to a single plane along the direction of propagations. As for the circular motion, the propagation of electric fields is in circular motion, and as for the elliptical polarized light, the electric field of light follows an elliptical propagations. So as we can see in this figure, the electric field of linearly polarized light is confined to the y-z plane along the direction of propagations. The electric field of circular polarized light consists of two perpendicular which equal in amplitude and have a phase difference of pi/2, result in electric field waves propagates circularly. However, for the elliptically polarized light, happens if the two components have different amplitude, since it has a phase difference other than pi/2. For example, 3pi/2, 5pi/2, and etc. Next, moving on to the polarization of light in liquid. In this experiment, we use liquid crystals, as we can see the interaction of the polarized light with a liquid crystals, as it can alter the polarization of light. So there are three types of liquid crystals. We are thermotropic, plyotropic, and metallotropic. So thermotropic describe the phase transition by using temperature, while plyotropic describe the phase transition by using concentrations of the mixture. And metallotropic does not only depends on the concentration and temperature, but it also on inorganic composition ratio.
Hi, I'm Kushinja. So to observe the change in light intensity when passing through the two closest polarizers, first we need two pieces of polarizer, and then we stick one polarizer to the laser. So when we rotate the laser, the polarizer will rotate it together. And then we stick another polarizer to the light sensor or phone. Here I stick the polarizer on the light sensor of the phone, which is near the front camera. And then we use the Arduino SciJournal app to detect the brightness, which is the light intensity of laser. And then we shine the laser to the line sensor and rotate the laser 180 degrees. And then this is the result we get as I rotate the laser in quite a steady motion. So the result is look like the expected sinusoidal square graph. So now we confirm that our polarizers work normally. And then to observe the intensity of light when there's a optically active liquid in between two polarizers. First, we fill a cup with 300 ml water and put it on a stool with a hole at the center. There's a hole at the center so that when the laser is shined to the water, the laser can pass through the hole and detected by the phone, which is put underneath the stool. And then the laser is rotated clockwise 90 degrees. We repeat this two steps by dissolving 30 grams of sugar into the water. This is the result when we shine the laser through the normal water without sugar one. As I shine the laser starting with the two perpendicular polarizer, and after 90 degrees it ends with parallel polarizers. So we can see increasing trend. This graph is not as beautiful as just now because it is hard to aim the light sensor on of the phone during this setup, but we still can observe a increasing trend. However, when we shine the laser through the sucrose, the sugar solution, the trend is not like just now, only increasing. Now the brightness first decreased and then it increased. We repeated it twice to make sure the effect. These results are expected, and we can explain it using the diagram below. The green line is the polarized light by the water, and the red line is the polarized light rotated by the sugar water. So after the first polarizer, it passed through the water and the water has no effect on it. So when it passed through the polarizer at the line sensor on the phone, at first it is polarized again, so that the light intensity is the minimum. And then when I turn 90 degrees, it become parallel. The two polarizer become parallel, so that maximum light intensity is observed. When the polarized light is passed through the sugar water, the polarized light is rotated a bit, from the view of the light source, it is rotated anti-clockwise a bit. So its minimum will become here, where it is perpendicular to the second polarizer at the light sensor, which agree with our result, which is somewhere between here. So we start from here, and then we get a minimum during here, and then we get a almost maximum at here.
Hello, my name is Mohamad NASRULLAH. So now we will going to discussion part. So for this experiment, there were actually three parts, which is normal polarization, polarization with water, polarization with sugar water or sucrose. So before that, we need to know that actually sugar water here act as optically active liquid. So first we need to define what is optically active liquid. So in general, we can define it as the ability of a substance to rotate the plane of polarization of a beam light that is passed through it. So this experiment was conducted with the objective to see how the change angle of the polarized filter can affect the light intensity that passed through the polarizer filter. And in order to make it more varied, we decided to use sugar water that act as optically active liquid and see how it will affect the reading of our data. So for the first part, from the graph light intensity versus time, so here we know that as the time increase, the angle between the direction of polarization and the axis of the filter increase. We can see that as the angle increase from 0 degree to 90 degree, the intensity of the light increase, and from angle 90 degree to 180, the intensity of the light decrease. This caused the graph to be square of sinusoidal graph. This is because the lower reading of intensity of light was 0 and there was no negative value for intensity of light in our experiment. So the lower point of the graph just belong to x-axis, which is y equal to 0. So from this graph, we actually can calculate the intensity of polarized light after passing through a polarizing filter by using formula I equal to I naught cos squared theta. So the reason why the intensity of light that passing through the polarizer filter was decreased as the angle between two polarizers increased from 0 degree to 90 degree was because the polarization plane for both filters was perpendicular to each other. Since both of them just can let the light pass only in one plane, then when the plane of polarizer that allow light to pass through it was not in the same orientation, it will block the light. That's why as the angle changed from the 0 degree to 180 degree, the intensity of light increased and then decreased to its origin intensity. So for part 2, since the water is not solution that optically active liquid, thus the result was just the same as part 1. This is because water do not have element that can rotate the plane of polarization of light passing through them. So for part 3, we did use sugar solution or sucrose as the optically active liquid that we put it in between two polarizer filters. Since we know that optically active liquid has the ability to rotate the plane of polarization of a beam light that is passed through it, then in general we should know that there must be a difference in data collected. So from the graph light intensity versus time, where as the time increase, the angle of the polarized filter that attached to the laser will rotate from 0 degree to 180 degree. We can see there was a slightly change or difference on the graph obtained. We can see here the trend of the graph not exactly same as part 1 and part 2, since it have minimum point at the middle of the graph. In part 3, the graph decreased first and then increased after certain time. This is expected since the solution will rotate the plane of polarization. So next we will move to the future work. So here we have twisted pneumatic LCDs can be used to control the AOP of transmitted light. So AOP here is the angle of polarization. So a twisted nematic panel that can be converted to an angle of polarization monitor. So that one for A. So for B, when a voltage is applied above a threshold, the molecule starts to reorient, becoming perpendicular to the glass substrate. Imagining polarimetry showing red, green and blue subpixels in a twisted nematic panel convert to an angle of polarization monitor via removal of front polarizer. So AOP and DOLP characterization of the monitor's output across the 256 interval input scale, showing the gradual change in rotation of AOP of light as the input value increase. And then AOP is angle of polarization, while DOLP is the degree of linear polarization. So next we have PVA. So in pattern vertical alignment LCDs, the liquid crystal molecules are oriented parallel to the light path in the default state when no voltage is applied. As a result, the polarization of transmitted light is not modified by the liquid crystal, producing a dark pixel. So for B, for different applied voltage, the liquid crystal layer retards output light to a different extents, altering its DOLP. So for C, front view of a pixel, showing the liquid crystal alignment and polarization state of output light. And for A to D, the width of the electrode is approximately 100 micrometer and each pixel is 293 micrometer tall and wide. So as the conclusion, we can see the change in light intensity when passing through cross polarizing filters at different angle due to plane of polarized filter. And then we can see that the optical active liquid affect the intensity of light that pass through the polarizer filter. So that's all from our group. Thank you.